All right, so we're going to find the volume that's generated by these two curves, y equals x squared and y equals x to the fifth. First thing we needed to decide is which of the two curves is on the top, which is on the bottom. If you pick a number that's in between here, like 0.5 or 1/2, and plug it into each of these two equations, y equals 1/2 squared is going to give you 1/4. If I plug 1/2 into x to the fifth, I'm going to get 1/32. The larger of those values is 1/4, so y equals x squared is this curve that's on the top. Y equals x to the fifth is this curve that's on the bottom. So my volume formula then will go from, my rectangle ranges from 0 to 1. So my bounds of integration are 0 to 1. My big radius is the top of the rectangle, which is x squared. My little radius is going to be the curve that the bottom end of the rectangle touches, which is x to the fifth. So it's the big radius squared minus the little radius squared. So as I square these two values, I'll have x to the 4th minus x to the 10th. And then you could put this in the calculator, or you can integrate it. This one's not too bad to integrate. Add 1 to the exponent, divide by the new exponent. And we're integrating from 0 to 1. So if I plug in 1, I'll have 1/5 minus 1/11. If I plug in 0, I get 0. And then this is just going to be, let's see, 55 would be my common denominator, so 11 minus 6 in the top, which is going to give me, 11 minus 5, which is going to give me 6 pi over 55 for that volume. Number 6 you had, but we had that in the notes, so I'm going to skip that one. Number 13A, we're rotating around the x-axis. My curves are y equals x squared, which is the bottom curve. And then y equals 4x minus x squared, that's this top curve, the parabola that's opening downward. If I draw a sample rectangle inside this shaded region here, anywhere inside I like, the top of the rectangle touches the parabola that opens down, and the bottom of the rectangle touches the parabola that opens up. So my big radius is going to be the far end of the rectangle, which is touching the curve that opens downward, which is that 4x minus x squared. My little radius is going to be the other end of the rectangle that's closest to the axis of rotation, which is the parabola that opens upward, which is x squared. So my volume then would be pi. I need to figure out my bounds for integration. So these points of intersection are 0, 0. This point up here is 2, 4. So the rectangle ranges from left to right, so my values from left to right are 0 to 2. My big radius squared would be that 4x minus x squared. Quantity is squared, and then my little radius would be x squared. And as I said before, you can put this in your calculator if you want. If I type this equation that's in blue into my calculator in y equals, so I need parentheses, 4x minus x squared. Close off that parentheses and square it, and then it's minus, and then it's x squared squared. I'm just going to put it in as x to the 4th. Okay, and integrate, second, and calculate. Number 7 is integral, and my lower limit is my lower bound, which is 0. My upper limit is 2, which is my upper bound. And then it gives me an answer of 10.6 that repeats. Remember, you can turn that into a fraction, hit the math button, and number 1 is fraction, and then hit enter. The only thing that it hasn't done is it hasn't multiplied by pi, so 32 pi over 3 for that volume. And on your quiz, that's all you need to show me is the diagram, the graph of the equations, your sample rectangle, the setup for the integral, and then the solution there. All right, 14a, same idea. Draw that sample rectangle in here, rotating around the x-axis. Draw that rectangle so it's perpendicular to the axis of rotation. The parabola is the top end of the rectangle. 6 minus 2x minus x squared. The bottom of the rectangle touches the line, which is x plus 6. So my volume then would be pi. These points of intersection here, this is negative 3, 3. This point of intersection is 0, 6. So my x ranges from negative 3 to 0. My big radius then would be the end of the rectangle to the axis of rotation, which is just this curve right here, the 6 minus 2x minus x squared. My little radius then would be the other end of the rectangle closest to the axis of rotation, which is the line x plus 6. So then if I plug into my formula, big radius squared minus my little radius squared. Okay. Again, I can put this right into the calculator, so let's do that. So in y equals, I'm going to clear out this last one, 6 minus 2x minus x squared. And then I'm going to square that. And then minus my little radius, which was x plus 6. Okay, one thing I do have to check is my window. My window has to include my bounds for integration. My window is only, my x's are going from 0 to 5. I need to go from negative 3 to at least 0, if not bigger. So I'm going to change this. I'm going to make this negative 5 to 5. So my x values include those bounds for integration. So second and calculate, and then number 7 is integral. So now when I type in my lower limit, that value is actually on my graph there. So negative 3 is my lower limit, upper limit is 0. 48.6, we'll change it to a fraction. And then don't forget to multiply by pi. 243 pi over, what is it, 5 or 3? Over 5. That's my volume. All right, 24, you had 2 regions for this one. But what we can do, you have symmetry, so I could either do this in 2 pieces, or we can just do it in 1 piece and double my answer, which is what I'm going to do. So I could integrate this from 0 to 3, and then just double it. So 2 pi from 0 to 3. Now this one is not a washer method. We're going around the x-axis. I only have 1 radius because the rectangle touches the axis of rotation, so it's actually a disk method problem. And disk method just has a big radius squared. So that big radius squared is just this x square root of 9 minus x squared. And that's what I'm going to integrate. I got my integral set up. We can put this in the calculator and integrate it. Clear this out. I got x times the square root of 9 minus x squared. Sure I got the parentheses in the right spot there, and then it's squared. I'm integrating from 0 to 3. Lower limit is 0. My upper limit is 3. So I get 32.4, let's change it to a fraction. So 162 over 5. Right, and then I also need to multiply by 2, so I'm going to just double this thing. And you do it with the calculator, or you can do it by hand here. So we'll have, what, 324 pi over 5. Okay, for 25, we're rotating around the x-axis again. We're going from 1 to 3, so this is x equals 1, this is x equals 3. Y equals 0 is my x-axis, 1 over x is my curve on the top here. So if I draw a sample rectangle in there, the bottom of the rectangle touches the axis of rotation, so this again is a disk method. So my volume is pi. X goes from 1 to 3. The top of my curve touches the 1 over x. And it's squared. I don't have a small radius. I only have r of x. Okay, and you can integrate it with your calculator. So we'll type in 1 over x. That quantity is squared. And we're integrating from 1 to 3. And we get 0.6 repeated, which is 2/3. If you're not sure, you can change it in the fraction part of the calculator. So 2 pi over 3 is our volume for that solid. 26 is almost the same problem. We're going from x equals 0 to x equals 6. Y equals 0 is my x-axis, x equals 0 is the y-axis, my curve 2 over x was 1, and we're rotating this around the x-axis again. Draw that rectangle perpendicular to the axis of rotation. The rectangle's touching the axis of rotation here. So again, it's a disk method. So my volume will be pi, goes from 0 to 6. Upper curve is that 2 over x plus 1, and it's squared. And again, put this in the calculator. If you had to integrate this by hand, it would be much more complicated. Type it in y equals 2 divided by, I need parentheses around the x plus 1. And I put a parentheses for that too, so I'll close that parentheses off. That whole quantity is squared. And then we're going to integrate number 7 from 0 to 6. Oh, I don't think my bounds. Okay, so I got this error message. It just tells me my window wasn't big enough. So hit your window button. Hit your window button. And just change this so my x max goes larger than 5. I'm going to go up to 7. And now I can go back and integrate this thing. Just got to start over again. So if you ever get that error message, you know what they're talking about. Let's try this again. I don't know what I just typed in there. Right, lower limit is 0. Upper limit is 6. 3.428, we'll change that to a fraction. Okay, so it gives me this as a decimal. It won't convert it to a fraction. The reason why it won't convert it to a fraction is it's an irrational number to begin with. So we'll round this off to 3 decimal. Actually, you know what? Let's multiply it by pi as well. So times pi. So I'll round this final answer off to 3 decimal places. So 10.771. Okay, so if that happens, it just can't convert it to a decimal. It's probably some kind of irrational value there. All right, and then 27, this is probably one that's going to work that same way. So we're going around the x-axis. X equals 0, x equals 1. E to the negative x, that's my curve on the top there. There's a sample rectangle perpendicular to the axis of rotation. Again, it's disk method. Right, so we just have a big radius. That e to the negative x. So my volume will be pi from 0 to 1, e to the negative x squared. And then again, just type it in your calculator. My window should be okay. I'm going from -5 to 7, so it includes my 0 to 1. So in my y equals, we'll type in e to the negative x squared. E E is the second key in the natural log key. Let me fix this parentheses here. And then we'll put a square outside. Right, and I'm integrating from 0 to 1. There's my curve. 0.423, we'll try to convert it. 1. Okay, it won't convert, so let's just multiply it by pi, just estimate the entire answer there. So times pi, 1.358. For our volume. All right, the last one is really tricky. So the last one, I really have two regions. If I draw my sample rectangle in the part that's green, the curve that's on the top is the parabola that opens downward, which is the second one, negative x squared plus 2x plus 5. And the bottom of the rectangle touches the parabola that opens upward, the x squared plus 1. If I draw my sample rectangle in the yellow region, this real skinny piece here, the top of the rectangle touches the parabola that's the positive x squared. The bottom touches the one that's negative x squared. So I have to do this one in two pieces. So for my green part, this point of intersection here is at 2, 5. This is 0, and this is 3. So I'm going to integrate from 0 to 2. The green part, my big radius, would be the top of the rectangle, which touches the negative x squared plus 2x plus 5 squared, minus the bottom rectangle touches the parabola that opens upward, the x squared plus 1. And then I'm going to have to add to that the volume of the yellow region, which goes from 2 to 3. The top of the rectangle touches the x squared plus 1. The bottom of the rectangle touches the other one. Plus 5. So you just need to do this in two separate pieces here. So I'm going to integrate this down here. So if I do the first one, then the negative x squared plus 2x plus 5, it's squared, minus x squared plus 1, squared. Okay, and I'm integrating from 0 to 2 for this one. .667, let's change it to a fraction. 152 over 3. So this first part is 152 pi over 3. We're going to do the same thing for the second piece. We'll just add these two volumes together then. So I just got to type it in the opposite order. X squared plus 1, and it's squared, minus the negative x squared plus 2x plus 5. That's squared. Integrate. And we're going from 2 to 3 this time. Okay. Change it to a fraction. So 125 over 3. So it's 125, forget the pi out in front, over 3. So if I add those two together, I'll get that total volume then of those two regions rotated separately. So we get what, 277 pi